So this is both the part 2 lecture for the day I am gone for my Chem 111 lecture about nomenclature, but it is also a duplicate for the nomenclature information that is needed for the nomenclature lab, which is virtual for this summer of 2023 semester. All right, so we are going to go through all of the nomenclature rules so that you have a better idea on what we are applying to both homework sets and the nomenclature lab. All right, so for those of you who do have me for lecture, we did cover a bit of this last week, but I figured I'd backtrack just a little bit so that everybody has the whole set of information. So one of the things that we've been doing over the beginning of the semester here is first looking at elements, what elements are made of, some background, a little history. Now we have reached the point where you need to begin to apply that information to naming of entire molecules. There's a basic first step that involves, if you want to make a molecule, how about just use two of the same thing? This is referred to as a diatomic molecule. Most gases occur this way. Okay, not the noble ones. I'm a mnemonic person, so I like the old brown finch as a way to help you remember which elements tend to do this a great deal. We have old brown finch, so oxygen, bromine, fluorine, iodine, nitrogen, chlorine, not carbon, and hydrogen. We're also going to take a step away from the idea that your protons and your electrons are supposed to match, because we want to create the possibility of charges. So when your number of protons doesn't equal your number of electrons, you will have an ion. This means it has a charge to it. So we've got two basic types. We've got cations. Please do not call them cations. They are cations. And anions. So more brain tricks. Cation has a T in it, which also hopefully reminds you that this is the positive version of the ion. Cations have had one, maybe more, electrons lost or stolen. And I picked on a couple of elements near the top of the table here to kind of take a look at. If you have a lithium atom and you steal one of its electrons, so it still has 3 protons, but now that third electron is somewhere else. What it is doing is allowing that third proton to kind of let its light shine through so that you can actually see the positive charge of that third proton. How about if you have calcium? Calcium has 20 protons, 20 electrons to start with. It has a tendency to lose 2. So the 20 protons remain, but now you've only got 18 electrons. This is where your positive 2 charge comes from. How about on the opposite end? Things that are anions. So anions are the negative ones. 1 or more electrons have been gained. Hint, hint, they are often stolen from the metals. So fluorine has 9 protons and 9 electrons to start with, but it has a high tendency to steal an electron. Hang on a minute, I need to pause this.